Alright guys, today we're going to talk about parent functions. More specifically, we will analyze parent functions. We will analyze parent functions. There it is, right there. Match the graph with the name of its respective parent function. Okay, so the first one here you should know already. It is called a quadratic. So let's go ahead. It's a parabola, right? So it is a quadratic, which over here in our list is B. All right, and you should notice when we have equations, the degree is going to be 2. So like the highest exponent you see is going to be a 2. The degree is going to be 2. We've talked about these already, so hopefully this one you've got down. Now on the next one here, we've got a cubic. All right, and when you see a cubic like this, the highest exponent, that is going to be 3. So the degree will be 3. All right. Over here, we've got a quartic. Oh, by the way, cubic was C in our chart here. This next one is D, quartic. And when you see this one, the highest exponent, aka the degree, will be 4. And this is one you know from a long time ago. It's linear. Okay, and the highest exponent is going to be, or the degree is going to be 1. So that's an oldie but a goodie. All right, so these are the 3 we're going to talk about. Now I want to remind you as you're watching the video, remember that you can always rewind, rewatch, do what you need to do, pause it. I'm going to go at a pretty fast clip because I got to get everything in, but remember you can pause it and rewatch it and all of that. All right, so mathematical side note, if you figure out the degree of a function by count how many switches there are, know that that is the maximum amount of switches we have. We won't work with much of this in class, but just wanted to let you know this. What does that mean? 1, 2. It's like where we change, where our turning point is. 1, 2, 3. 1, 2, 3, 4. 1. All right, so highest degree 2, highest degree 3, highest degree 4, highest degree 1. This isn't always true, but you could kind of eyeball it and maybe look at it that way. So the degree of a polynomial, we just talked about it. It's the highest exponent of a polynomial. Oh, and I almost forgot to mention, make sure it's in descending order from highest exponent to lowest exponent before you answer these questions. It tells us the total number of roots, okay? This is, so for example, if you have a degree of 3, then you have 3 total solutions. Okay, that's what this means. If you have a degree of 3, you have 3 total solutions. If you have a degree of 4, you have 4 total solutions. If you have a degree of 5, 5 total solutions. Okay, so that's what that means. Leading coefficient of a polynomial is the number in front of the term with the highest exponent. If you have it in descending order, it's the leader of that descending order. It says use your calculator to make a sketch of the polynomial, then identify the following information about each polynomial. So we'll go on our calculator. I'm going to clear mine out real quick by hitting second plus 712. I'm going to hit my y equals, because f of x is y, and wait a minute, they said, hey, put it in descending order. So let's rewrite this really quickly. What's the highest exponent here? It's a 2, so the negative 3x squared will go first. Then the next highest exponent is this, a 1 on our x, so negative 10x. And then last but not least, we have a negative 2 right here. Okay, so this is what we're going to put in to y equals on our calculator. So I'm going to type in negative 3x squared minus 10x minus 2. And then we're going to go ahead and graph it. Now, if you've cleared your calculator out, you'll have a nice standard graph right here. And this is what it looks like. Well, let's discuss. Highest exponent here is a 2, correct? So let's go down here. Let's answer some questions really quick. And we can go ahead and we can sketch this graph. Let's see. Kind of looks like this, right? That's what it looks like. So name of the parent function. We'll look at the shape and then go back up here and look. It's a quadratic. Okay, it's a parabola. So this is a quadratic. Degree, or the total number of roots, right here, highest exponent is 2. Highest exponent tells you how many answers you will have. And then they want to know how many reals and how many imaginaries. So we talked about this in the past. There are 2 x-intercepts here, so there must be 2 real solutions. Remember, this has to add up to the degree. Add up to the degree. This is important. Okay, so if a quadratic has a degree of 2, then this must add up to this 2. This is why we have it indented here for you. So if there's 2 reals, there must be no imaginaries. And the leading coefficient. So the leading coefficient is the number that's in front of the term with the highest exponent. So our leading coefficient here is -3. Remember, if I'm going too fast, pause it, go back, rewatch. It's totally up to you. Now down here we have end behavior, which we have discussed before, as x goes to -infinity. So what does this mean? It means as we go to -infinity, so it's to the left, do we go up or down on the graph? So let's see. As we go left, we go down, right? As we go left, we go down. So we're going down to -infinity. This one is going to infinity on x, so that means as we go to the right, do we go up or down? So over here, as we go to the right, we're going downward, so -infinity. Some of you can look at it and tell too. So just look at this graph and you can see they both are pointing downward, okay? So that's another way of doing it. Okay, so let's go ahead and let's look at our next one here. It says, hey, put it in descending order. So highest exponent will go first. Highest exponent here is x cubed. So the 7x cubed will go first. Next highest would be x squared, so plus 3x squared would go next. Next one is -x, and the next one would be -2. This is what we're going to put in to our y equals on the calculator. So I'm going to scooch this over. Let's go over here, y equals, clear it out. So we've got x cubed plus 3x squared minus x minus 2. So then if we graph this, this is what it looks like. So it comes up, does a little twist, and then goes back up. So if we sketch this, it looks something like this. All right? So if you kind of count how many switches are here, there's 3, but you can also look at the highest exponent and see that it's 3. So if we go up here, we've talked about if your highest exponent is 3, it must be a cubic. Now some of these won't always look the same, but that's why I like going off of the degree. If the degree is 3, it must be a cubic. Again, I just said the degree is 3, so that means these two must add up to 3. All right? Has to add up to your degree. So if we look over here, we only have one x-intercept. So if we only have one x-intercept, we only have one real root. Well, if this has to add up to 3, then there must be 2 imaginary roots. Let's talk about the leading coefficient. It's always the number that's in the front, the one in front of your highest exponent. So our leading coefficient here would be a 7. And let's talk about this. As x goes to -infinity, -infinity would be the left, this one would be the right, and then we got to talk about does it go up or down. So as we go to the left on our graph, notice we are going down. As we go left, we go down, so -infinity. As we go right, we go up, so +infinity. There you go. All done with that one. Remember, if I'm going too fast, go back, pause it, rewatch it, do what you need to do to learn. You're in control of your learning. On this one it says identify the degree, the type of root, and the end behavior of the following polynomials. So if we look at this, 1 turning 2 turning 3. So this seems like it has an exponent of 3 as its highest exponent, which means it will be a cubic. If we look at this graph, we'll see that there are 3 x-intercepts, so there's 3 real roots. So if this has to equal 3, and there's 3 real roots, there must be no imaginary roots. Let's talk about this. As x goes to -infinity, -infinity is this way, so as we go to the left, this one's as we go to the right. As we go to the left, we're going up, so +infinity. As we go to the right, we're going down, so -infinity. Okay, let's look at this next one. Name of parent. Well, look, I just go in one direction all the time. One direction, not to be confused with the group. So this one right here is linear. It goes one direction, and that means there's one real root. I don't know why they didn't put imaginary roots here, because you should know there's 0 imaginary roots in. Oh, here it is. It's just not indented. Whoopsie. So these two should equal 1. Okay, so as x goes to -infinity, -infinity is the left, +infinity is the right. So as we go left, we go down, so -infinity, and as we go right, we go up, so +infinity. Over here on this one, we go 1, 2, 3, 4. So I'm counting it with each time I change direction. Every time I change direction, that's what I'm counting. So I'm counting 4 there, and I don't know why this isn't indented in. It should be. So if it's 4, then it's a quartic, like a quarter, 4 quarters in a dollar. So quartic. And if I look at this, I only see an x-intercept here and here. So there's 2 real roots, and since this has to add up to that, there must be 2 imaginary roots also. As we go to negative infinity, so the left, oh, and look at this, there's another typo here. This should be a plus sign right there. So if that's messed up on your paper, go ahead and change that. So as we go to negative infinity to the left, and as we go to positive, make sure you change that, infinity on the right, what's happening? Well, it doesn't matter which direction we go. If we go left or right, we're going downward on both of these. So negative infinity, negative infinity. Okay, so on the next one here, use your calculator to sketch a graph of the polynomial and find the following information. Okay, so we got all kinds of things going on here, so this ought to be good. So we're going to go in the calculator, we're going to hit y equals, and we're going to pop this in here. So I've got x cubed plus 2x squared minus 5x minus 6. I'm going to go in here and graph it. And there it is, looks something like that. So let's just do a rough sketch right now of what it looks like. And what it looks like to me is this. Okay? Looks about like that. I'm a little off here, but it's good enough for now. Okay, so now that we've done a rough sketch, let's see what they want to know from us. I'm going to zoom out of this a little bit so I actually see what's going on. Name of the parent function. So we go 1. We change directions. 2, we change directions. 3. So the degree must be 3, which means this must be a cubic. We do have 1, 2, 3 x-intercepts, so we must have 3 real roots and no imaginary roots. And look, they want to know our max and our mins. This should be good. So looking at this, you should see that there definitely is a max here and a min here. All right, that's the lowest it'll go and the highest it'll go. And we've talked about maxes and mins, and we can handle this. So we go in the calculator, we hit second calc, and then we want to do, let's do our max first. So option 4, remember we go to the maximum, and we pause there for a brief moment, and then we go a few to the left and hit enter. Then we go back to the maximum, we pause there for a brief moment, and we go to the right of it and hit enter. Then we hit enter on guess. So negative, let's say negative 2.1, comma, 4.1. Negative 2.1, comma, 4.1 is our max. Let's write that down here also. Negative 2.1, comma, 4.1 is our max. Let's look at our min. So on the calculator, we go second calc, we do minimum, and then we're going to go over here to the minimum, put our cursor on it, and then we're going to pause there for a brief moment. And then we're going to go a little to the left and hit enter, and then we're going to go back to the minimum, and we're going to pause there for a brief moment, and then we're going to go a little to the right of it and hit enter. And then we hit enter on guess. And when we do this, let's say this is 0.8, negative 8.2. So this is 0.8, negative 8.2. So we're going to go back down here, 0.8, negative 8.2. All right, they want to know our end behavior. So look at this. As we go to the left, we go down. As we go to the right, we go up. So as we go to the left, we go down, so negative infinity, and as we go to the right, we go up, so positive infinity. And there you go. This one here, I don't think we're going to get to cover in class, so I'm going to leave this one blank. Check with your teacher if you're watching this video and find out if we filled this in or not. All right, until next time, bye!